From the question, the first thing we want to do is to what? Find our distribution function since we're dealing with what? Normal population. And our distribution function we said is what? F into x mu sigma squared. Another thing? Another thing? No. Okay, let's just leave it like this. Then this is what? Equal to what? 1 by what? What do we have? Sigma root what? 2 pi. Okay, exponential minus x minus what? Mu squared over what? 2 sigma squared. So these are exponential, our normal distribution function. So I said I can rewrite this thing in a more simple, I can put it in this form. Look at this. I can put it in the form 1 over 2 pi 1 by 2 1 by theta 1 by sigma exponential. Now up here now I can put minus 1 by 2 sigma squared, then x minus mu squared. And I said, am I correct? Is this correct? Do you know what this means? This is same as what? Root, right? Yes. Root of 1 is what? 1. Root of this will still be what? Root of that. Yes. That's all. So I know I put it like this so it'll be easier for me. So what's the step 1? Step 1 says what? Take the likelihood function. That is L of LP is equal to what? We multiply by pi, I run it from 1 to what? N into what? 1 by 2 pi 1 by 2. This is 1 by what? Theta 1 by sigma, then exponential what? Minus 1 by 2 sigma squared x minus what? Mu or what? Squared. So that's it. So it's more like this. So we're going to multiply this into the distribution function. And so what are we going to have? If this operates on this here, what are we going to have? 1 by 2 pi n by 2. Right? Yes. Then what do we have? 1 over what? Theta by what? Sigma by what? N. Have you? And this exponential minus what? Okay, this is it. Let me put it well. Exponential minus 1 by what? You know something here? This guy is attached to this guy. So what do you think it should operate on? What should it operate on? Is it going to operate on the two of them? Or is it going to operate on this guy alone? Yes. And now I know you know the reason why. So it's going to be summation, right? X minus mu squared. So that is it. So from here now, we are taking our what? Look, likelihood function. Now we can simplify this now. What's the next thing we'll do now? Step 2. Take the log. Now take the log of this one here. Take the log of this one. N by 2 ln what? Sorry, let me put it well. So now let's take the log. Ln LP, right? Is equal to what? N by 2 ln what? 1 over 2 pi. Since it's multiplication becomes what? Plus. What do we have? Rewrite this thing. It's going to be what? X minus n. It's going to be sigma minus n. Hope is true. Is correct, right? Yes. So this becomes minus n, then sigma. Minus n in what? Sigma. So next is what? Exponential whatever. These things will what? Come down. So it's be plus what? Exponential. Minus 1 over 2 sigma squared. Yes. Summation what? X minus what? Mu squared. Ln what now? Exponential. This is what? What is the value for this? 1. That's it. So the next thing number 3 is to do what? Partially differentiate with respect to what? The first one says we should differentiate with respect to what? With respect to mu. Right? Yes. Is it with respect to mu?
Yeah, the first one is mu.
Alright. So if we're differentiating likelihood function with respect to what? Mu, or let's take sigma. Let's do sigma. I prefer using sigma for the first time, so this is sigma. Alright, so if we take with respect to sigma, is there anything sigma here?
No.
So this will be what? 0 plus, is that sigma here?
Yes.
So it's going to be what?
Minus n.
Minus n.
E.
Minus n what?
E.
Lane sigma is going to be what?
1.
No, over sigma. Lane theta is 1 over theta. Lane sigma is 1 over sigma. You are forgetting that part. So now, next thing is what? Plus. What happens here? This guy is 1. You know, if I keep this constant, if I differentiate this, is there sigma here?
No.
So it will be 0.
Yes.
So the next part will be what? Plus. Then I'm going to keep what? This one constant. That is what? Summation x minus mu squared. You know this mu is same as s bar.
Yes.
So I keep this constant now. If I differentiate this one, what will I have? Or if you don't want to stress yourself with that, please look at this. Like it's a bit confusing here now. Let me write it now. Look at this. Okay, you know that this is like minus 7. I mean, it's minus. So this is what? X minus what? Mu squared over 2 sigma squared. So differentiate this by quotient rule. By quotient rule, this one will be constant. 2 sigma squared will be constant. To multiply what? This guy, if you differentiate this guy with respect to sigma, it will be what? 0. So this guy will not work. It's 0 already. Or let's put it 0. Then minus, let's put this guy constant. It becomes what? X minus mu what? Squared. Constant. Differentiate sigma. Differentiate the base now becomes what? Differentiate now becomes what? 4 what? Sigma. You understand?
Yes.
So 4 over what now? 4 sigma 4. You understand? All over 4 sigma 4. So if you have this over 4 sigma 4, so now if you look at this very well, 4 sigma can this can go 4, this can go, it's remaining 3. Have it? So now if you go with this, you have what? Minus n sigma minus what? What do you have?
X.
You have what? X minus mu squared over what? Sigma what? Cube. Next, instead first say we should do what? Equate it to what? 0 and simplify. What is the LCM here? Sigma what?
Cube.
Sigma into sigma cube will remain what? Sigma squared. Sigma squared times this becomes what? Minus n what? Sigma squared. Minus. This will go into it once. Multiply by this becomes what? X minus mu squared. Equal to 0. Cross multiply. That means if we cross multiply, the other one will go. Let's come back to this side. Or is it confusing? I should explain. Okay, you understand? Alright, so now look at this. If this will go now, so what do we have left? What left will be this? Minus n what?
Sigma squared. Minus x minus
Mu
all over
squared. The other one is not 0. So this is equal what? 0. So what do we do from here? We're looking for what?
sigma squared.
Sigma squared. So what do you think we should do from here? We can move this guy to the other side. So this minus n sigma squared is equal to what? Is this minus? Okay. Yes.
Minus.
Alright, that's minus. So if we move this side, what do we have?
We don't positive or
You said? You turn to positive or? Yes, let's go. It becomes what?
x.
Now, you know if I want to make this, okay, let's go. It becomes what? X minus what? Mu what squared. Right? So my sigma squared is equal to what? Negative what? X minus what? Mu what squared over what? N. So what's the next thing there? I have gotten my sigma squared already. Okay? So Getting this, I know that it's same thing as from here, because from here now we said something. We got this, you know, this -1, right? This negative n. Where do we apply the negative n? Where is it? Can we find it? Okay, this is a negative n. So we have negative here. Laying this, of which this letter gave us what? This value minus all these things. Now, look at this. Minus this guy. This will be constant. That is the first, the second type. Now this is constant. Differentiate this, it becomes this, right? So this is but look at something here, please. Look at something. You know that this is negative initially. I purposely skip this. I want to arrive first so that I will know what you think of this guy. So look at, you know that this is negative, right? Negative already, that's the initial, the original negative. I get it. So that negative here is supposed to be, let's say, somewhere here. Abi? So this is now what we have solved. You know that? So now, this is the negative we're having here. This guy goes, we keep this guy constant, this guy does not exist, it turns 0. It will minus. Then x minus mu will be there. Differentiate this, you get this. Cancel out whatever. That means this times this will be what? It will be what? Positive. I don't know why I did this. I skipped it. So this will be what? Positive. So if you come here, what will this be? Positive. So that this will be what? Negative. If you divide, it becomes what? So that this will go with this. You have this. So it's same as saying your sigma squared is equal to this. Now, can you remember what formula do you normally use in calculating sigma squared before? Is it not this?
Yes.
Then you are looking for variance. Variance is what? Root of this. X minus what? Mu. All squared by what?
N.
Is that not the formula? Now you have gotten what the formula. So now if I'm looking for mean, what is my mean? This is ML, this is ML. So we only, this is not part of the question. We just related that. So this one, what's the mean now? Mean is going to be what?
S.
Tell me what's the mean. What do you think is the mean? Mean is now going 1 by n summation what? X I. Okay, just xi, same thing. So that's the mean. So this is just what we are asked to find. We have gotten the 1 and 2. We started getting the 2. We get the 2, then we let out the 1. So it's very easy.
Explain this last one.
This last one.
Yes.
Now, what is sigma? Is this, right? I know that. Look at this, please. From here, you know that if I have 1 by n, n to what? X minus what? Mu what? Square. Right? Now, the condition for sigma for getting variance is that what? It must minus what? The initial, that is the x bar. You know what? Each of the x minus the x bar. So now, if I am not finding sigma, that means I am not finding any sigma here now. It becomes sum of the x's. Do you understand? That is why this can be written as what? Summation x, because this will go up over what? N. And this is equal to what? X bar. You understand what happened there? So that is just it. As simple as it is. So that is that for that. That is how to find by method of maximum likelihood estimation. That is for this guy. So first of all, you see this particular question, we are not given the distribution function. So we are the one that formulated the distribution function ourselves because we know it. So anyone they give you, you should recall the distribution function, and that will help you to solve questions like this. So that is it. Any question? It's clear. All right. Thank you.